Okay, Bismillah ar-Rahman ar-Rahim. Inshallah, we'll start 1.4. We'll do the separable differential equations. I split the section into 3 parts. One part which I will talk about separable equation, how to solve it in general. The second part, which is dealing with the constant solution, singular solutions, what they mean by singular solution. I will do some examples about that. The third one, which is the applications. These 2 applications, which is growth and decay, and Newton's law of cooling. Okay. So now, what we mean by a separable differential equation, if I can write dy over dx as function of x times function of y. Or in other words, I can write f of x times dx in another format plus function of y times dy. I can separate the function of x with the dx in one side and the function of y with the dy in another side, which is like this. If I can do this, the idea of solving it is just what? Integrate. That's it. Nothing else. You just integrate, you'll solve the differential equation. Note, usually when we integrate, we have a constant of integration. No need to have it in both of them. Just take it in one of them. That's it. Sometimes they can ask you to find an explicit solution. So you need to solve for y. Sometimes you can just make it as an implicit solution. Okay. Independent the solution where they want it, especially for the MCQ exam. Yeah, they can force you to make it explicit. Okay. The idea, as I said, is very simple. Just we write the y in one side and the x in one side, and we just solve for and just integrate. That's it. If you want, you can solve for y. This is the first one. Sometimes you can link it with the initial value problem. Yeah, just to find the constant. So if you look at this one, I have dy over y equal minus 6x dx. It means what's separable? I separate the y in one side and the x in one side. How to solve it? Integrate. So I have ln absolute value of y equal minus 3x squared plus c. You notice one thing. That implies what? That implies absolute value of y will be c is minus 3x squared. Or you can make it e to the power c. If I choose c to be plus or minus e to the power c, so no need for the absolute value. So y equal c is minus 3x squared. Now use the initial condition. Y at 0 equals 7. So that implies what? 7 equals c. That's it. E to the power 0, which is 1. So my solution will be 7 is minus 3x squared, which is a solution of both the initial condition and the differential equation. Okay, this equation, first you notice I can do it 3y squared minus 5 dy equal 4 minus 2x dx. Now it's very clear, it's a separable equation. What you will do? Integrate. You get what? Y cubed minus 5y equal 4x minus x squared plus c. As I said, with the c in one side, in this side of that. Because they put in the other side, take it to the other side and call the difference between these two constants another constant c. Okay. So no need to write both of them. I don't need that. Okay. Now solve this one. Now it's just a matter of calculation or matter of algebraic things. So you have what? X squared dy over dx equal 1 minus x squared plus y squared 1 minus x squared. And that very clearly, or very clear, that will be, or this one is by grouping, I can make it what? 1 plus y squared. Grouping, which we did in the pre-calculus. Okay, now I have what? Dy over 1 plus y squared equal 1 minus x squared over x squared dx. خلاص, now I make it separable. I separate the x in one side and the y in one side. Integrate. Integrate to get what? Or I can simplify this one. It's x minus 2 minus 1 dx. Now integrate to get what? Tan inverse of y will be, what's the integral of this? Minus x is minus 1 minus x, don't forget, plus c. So it means I can write it in an explicit solution. It depends on the question in this way. Minus 1 or 1 over x will be the same idea. I think it's very clear. Okay, this one also I have initial condition, so I can find the constant. We said the initial value problem. So you have what? First, you need to check is it separable or not. I divide by EY. This is times dy. I divide by cosine x in the other side. Now, very clear, this is separable. I put the y in one side and the x in one side. So that will be EY minus y, ES minus y, dy. This is what? This is 2 sine cosine. So all of this is just 2 sine x. Dx. Integrate. How to integrate this one? I need the tabler. So I have y is minus y. This is u and this is dv. So it's minus ay, e is minus y, minus e is minus y. This is 1, this is 0. This is plus, this is minus. Integrate. So you have, this is ay. This one minus or plus. Yeah, it will be minus all of this, which is minus y is minus y. There is a minus sign outside. Minus is minus y equal. What's the integral of 2 sine? Minus 2 cosine x plus c. So the answer is ey plus y is minus y plus e is minus y equal minus 2 cosine x plus c. Plug this. Y at 0 equals 0. So I have y at 0 and x is 0. That will be 1. This is 0 plus 1. Cosine 0 is 1. So c is 4. So my solution would be this. 4 minus 2 cosine x. That would be my solution of the initial value problem. Okay. Solve this one. Y prime equal x over y all square. Okay, so that is what? X square over y square. So that implies dy over dx is x square over y square. Okay. Yeah. So I can separate it. Yeah. Y squared dy equal x squared dx. Now it's very clear. This is separable. How you solve it? Integrate. I have y cubed over 3 over x cubed over 3 plus d1. equals C1 because I can write it in a different way. If you want an explicit solution, that give me multiply by 3. So I have y cubed equal x cubed plus 3c1. I call this c. Okay, call it c. So that implies in the y cubed equal x cubed plus c. So that implies in the y will be cube root of x cubed plus c if I want an explicit solution. Okay. This one. Yeah. Let me do the part A. I do part A. I have x plus y dy over dx equals 0. Okay. That implies y dy over dx equal minus x. That implies y dy equal minus x dx. Now it's separable. Now it's very clear this is separable. Integrate. What I will get? I will get y squared over 2 equal minus x squared over 2 plus a constant, call it c1. So that implies in the y squared equal minus x squared plus c. Or I have y squared plus x squared equal c. If I want to do it as an explicit solution, I need to be careful because I have y will be y squared will be c minus x squared, which implies I have two solutions. Y1 will be square root c minus x squared, or I can write y as plus or minus. Yes. So this will give me part B. If I want to write it as an explicit solution, I should do it this way, plus or minus. Now, with the initial condition, with the initial condition problem, very clear here that y is negative. So that means my solution will be what? Negative. Oh, first I need to find the c. Find the c. You have what? Yeah, I substitute here to find the c. You have what? 4 plus 0 equals c. So c equal 4. So let me do it. This one, give me this. Now use y0 equal minus 2. You get what? 0 plus 4 equals c. So you are getting x squared plus y squared equal 4. So that means y will be plus or minus square root 4 minus x squared. But y here is negative. So it means my solution is minus square root 4 minus x squared. The plus, no need for it, because y is what? Negative. So this is my answer. Which of the following differential equations are separable? I can separate them or not. Let us see. dy over dx equal what? I have y cubed common factor. The remaining x minus 5x squared. So that give me what? dy over y cubed over x minus 5x squared dx. خلاص separable. I can separate them. B. dy over dx equal to x ex squared e minus 3y. In other words, I have e3y dy equal to x ex squared dx, which is very clear, separable. The third one, dy over dx will be 1 plus x plus y 1 plus x, which is 1 plus x times 1 plus y. That implies I have what? dy over 1 plus y equal 1 plus x dx. So it's separable. So all of them are separable. Okay. I want to solve this differential equation. Okay. This one I can rewrite it as y squared 2 plus x squared. So I have what? dy over y squared equal 2 plus x squared dx. Separable. Integrate. To get what? Here I have minus 1 over y equal to x plus x cubed over 3 plus c. So I can write y as what? Minus 1 over 2x plus x cubed over 3 plus c. So this is my solution if you want an explicit solution. This one. 3e2y dy over dx equal x is minus dx is minus y. Multiply by e is y, so I have 3e3y dy. I get rid of this. Equal x is minus 2x dx. Now it's separable. Yeah, it's separable, just what I need. Integrate. This one I need the tabular idea. So I have x is minus 2x, 1, 0. So this is minus half, is minus 2x. This is 1 over 4, is minus 2x. This is plus, this is minus. So this integral, very easy. It's e3y. This integral will be what? Minus half, x is minus 2x. Is the plus, and minus 1 over 4 is minus 2x. Plus c. If you want to make it as explicit, just take len. I have 3y equal len of this. Or I can write it y 1 over 3 len of all of this. That will be my solution. Okay. This one. How to solve it? Okay. Can split it. Y squared sine y dy over dx. Or no need. This is dy equal 1 plus 3x squared x. خلاص. This is separable. Now I need to integrate this. I need the tabular. So y squared sine y. This is 2y, integral of sine, which is minus cosine. This is minus sine. And this is cosine. This is 2, this is 0. This is plus, this is minus, this is plus. So it's integral of this. It will be minus y squared cosine y plus 2y sine y plus 2 cosine y. That's the integral of this using the integration by parts on the tabular. This will be what? X plus x cubed plus c. Okay. I have y at 0 equal pi. Okay. Substitute it here. What you are getting? You are getting minus pi square cosine pi plus this is 0, huh? Cosine pi. Let me write it. Sine pi plus 2 cosine pi. This is 0, 0. That will be c. This is 0. So I have, this is -1, and this is -1. So I'm getting what? C equal 2 minus pi square. No, pi square minus 2, sorry. Yeah, this is -1, so it's pi square minus 2. So my solution would be minus y square cosine y plus 2y sine y plus 2 cosine y x plus x cubed plus the c, which is y squared minus 2. Okay. Yeah. This one, you can check that I can take y plus 3 minus y plus 3 over the same thing here. What you are getting? X minus 1, y plus 3 over x plus 4, y minus 2. So I have what? Y minus 2 over y plus 3 dy equal x minus 1 over x plus 4 dx. Now it's very clear it's separable. Now the thing is how to integrate these things, how to integrate these things. So let me do it here, then I'll put the solution now. Y minus 2 over y plus 3 dy. You can do it by long division since the degree are the same, or you can do this trick, which is write this one 3 plus 3 minus 5, which is minus 2 here, dy. And that give me what? 1 minus 5 over y plus 3. By the way, if you do the long division, you should get the same answer. And that now very clear. Y minus 5 ln y plus 3 plus c. The other one, the same idea. I can make it x plus 4. Yeah, it's the same thing, minus 5. That will make it easier for me later. That will be 1 minus 5 over x plus 4 dx. So it's x minus 5 ln x plus 4 plus c. Now plug them here. So you get y minus 5 ln y plus 3. I don't need the c. I take the other one. X minus 5 ln x plus 4 plus c. So I have what? Y minus x. This will be plus 5. Ln minus ln, I can make it ln division. X plus 4 over y plus 3. All of this equals to c. So this is my answer. Okay. This one. As you notice, the things is go back only just you need to so algebraic some algebra things to separate them, and then it's the integration method. Just you need to do some integration. That's it. This is the main idea in this section and solving separable equation. Okay, this one, if we look at it, this is dy over dx equal x over y tan inverse x minus x over 1 plus y tan inverse x. In other words, if I take x tan inverse x common factor, I'm getting 1 over y minus 1 over plus y. Or that give me x tan inverse x of what? 1 plus y minus y, that will be 1 over y, 1 plus y. Now I'm getting what? Y squared plus y dy equal x tan inverse of x dx. Now it's very clear, separable. So I need to do what? Integrate. So I have y cubed over 3 plus y squared over 2 equals. Need to integrate this. This is to integrate it, I need by parts. So let me do it Yeah, let me do it aside. Integral x tan inverse of x dx. Yeah, u is x. No, u is tan inverse of x. dv will be x dx. So v is x squared over 2. Here du is dx over 1 plus x squared. So then it will be what? Will be x squared over 2 tan inverse of x minus integral x squared over 2 1 plus x squared dx. Which is what? I can do the same trick as we did. That will be x squared over 2 tan inverse x minus half. This one, I can do it this way, or I can do it by the long division. Both are correct. So this is 1, huh? So you have x squared over 2 tan inverse x. X squared plus 1, this is 1, so it will be minus half. Let me do it in steps. So I'm getting x squared over 2 tan inverse of x minus half x plus half tan inverse of x plus 3. So plug it here. So I have x squared over 2 tan inverse x minus half x plus half tan inverse of x plus c. Okay, now use the condition to find the c. Y at 0 equal 1. So I have 1 over 3 plus half. This is 0. This is 0. This is 0 equals c. So c is what? 5 over 6. So the solution is y cubed over 3 plus y squared over 2 equal x squared over 2 tan inverse x minus half x plus half tan inverse x plus 5 over 6. Yeah, it's a little bit lengthy. Not difficult, but a little bit lengthy. Okay. X squared minus 2y prime equals square root of 8y. Okay, x squared minus 2 dy over dx equals square root of 8y. Okay. I'm getting what? I'm getting dy over y equal square root of 8 dx over x squared minus 2. Okay. That's it. This is separable. Yeah, this is separable. This is easy to integrate. This one I need partial fraction. So let me do it. So I need the integral dx over x squared minus 2, which is this one, x minus square root of 2, x plus square root of 2. So this one will be the integral. Yeah, partial fraction. This is A, this is B. We know how to find A and B. So just I substitute square root of 2. I'm getting what? 1 over 2 square root of 2. 1 over 2 square root of 2. Here, I substitute 1 square root of 2. So I have minus 1 over 2 root 2. So I'm getting 1 over 2 root 2. What is over 2? It's 1 over square root of 8. Huh? Yeah, because of that, we have square root of 8 here. So it will make it constant. Okay. Len x minus square root of 2 minus 1 over square root of 8 len x plus square root of 2 plus c. Yeah. Now I have len absolute value of y equal square root of 8 times this. 1 over square root of 8. And then x minus square root of 2 minus 1 over square root of 8. And then x plus the square root of 2. Plus c times square root of 8, it will be plus c. Okay. That will make it. So then absolute value of y will be absolute value x minus square root of 2. Then it will be then this cancelled, huh? So I have then the difference, huh? Which is then this over this plus c. Take e, I have absolute value of y is absolute value x minus square root of 2 over x plus square root of 2 e to the power c. Or I can write it y is plus or minus e to the power c x minus square root of 2 over x plus square root of 2. Call this c. So I'll call it a. Who cares? So this is a, this. No need for absolute value. So my solution, y equal a or c or any constant times this. This is my solution. My final answer. Okay. This one. 2 minus x. Yeah. Yeah, not difficult. 2 over dx. That will be 2 minus x times 1 plus y. So I have dy over 1 plus y equal 2 minus x dx. So at each problem, I want to be sure I wrote separable. Yeah, when I separate them. So then, so the value 1 plus y will be equal to what? 2x plus c. Okay. Take e, both sides. So I have the value 1 plus y will be e to the power c, e to the power 2x minus x squared over 2. I'll do the same trick as we did before with the plus or minus. I'm getting what? 1 plus y equal c, call it c of this. So my solution will be minus 1 plus c, yeah, which is an explicit solution, if you want an explicit solution. Okay, now we have many problems we want to do. Let's do them one by one. Okay, I think I have spaces. Yeah, I have 2 spaces. Good. So the first one, by the way, there's a mistake here. This should be minus. Okay. Okay. This one, dy over dx will be equal 64, which is 4 cubed. So I have 4x 1 over 3, y 1 over 3. So if I separate them, I have y is minus 1 over 3 dy equal 4x to the power 1 over 3 dx. Now I separate them. خلاص, this is separable. I want to integrate. Okay. I add 1, 2 over 3. So I make it 3 over 2. I'm getting what? 3 over 2. Y is 2 over 3 equal to what? Here I add 1, which is 4 over 3. So it's 4 times 3 over 4. X is 4 over 3. Don't forget plus. So I have what? This is cancelled, huh? Multiply by 2 over 3. Huh? Multiply by 2 over 3. You get what? Y is 2 over 3 equal to x 4 over 3 plus 2 over 3c, call it c. So this is my answer. This is number 1. Number 2, let me try to squeeze it here. Tan x y prime, huh? Tan x dy over dx equals y. So I have dy over y equal dx over tan x. In other words, tan x dx. Now it's simple. Integrate, you have what? Ln absolute value of y. What's the integral of cotan? Huh? Cotan is cosine over sine. It's the integral of cotan x dx. This is u. U is cosine, huh? U is cosine. No, u is sine. U is sine. Du is cosine x dx. Huh? So I have what? Integral du over u, which is ln of u plus c, which will sine. So that will be ln sine x plus c. Integrate. Oh, it has the condition. Inshallah, I can squeeze it. So I have absolute value of y. Take the e, will be e to the power c, absolute value of sine x. In other words, y will be plus or minus e to the power c times sine x, which is c. So that means, and we can write y c sine x. This is my solution. Solution of this equation. Now I will have y at pi over 2 equals pi over 2. So I have what? Pi over 2 equals c sine pi over 2, which is 1. So c equal what? Pi over 2. So my solution, y equal pi over 2 sine x. That will be my final answer. That will be my final answer. Okay. 3. dy over dx equals what? 2x over y ay minus x squared. Is it? Yeah. Seems a little bit complicated. It's not. This is what? 2x over y ay e minus x squared. In other words, I have what? Y ay dy equal, this one I take it up to x ax squared dx. Now it's integrate. I want to integrate this by parts, tabler, do it the way you like it. I know it is y ay minus ay equals integral of this, which is very clear. E to the power u, this is du. Huh? So it will be e to the power x squared plus c. So this is my answer. Integration. It's a matter of integration. 4. 4 half what? Y prime plus x ey equal x. Y prime plus x ey equal x. Have a condition? No condition. Okay. So I'm getting what? dy over dx equal x minus x ey, which is x 1 minus ey. Okay. So I have dy over 1 minus ey equal x dx. Here is the problem. How to integrate this? Let me do it here. Let me give a space for it. Integral dy over 1 minus ey. One trick to do, you multiply by e is minus y. numerator and denominator. So I have x minus y dy over x minus y minus 1. Now we'll take this as u. We take u, x minus y minus 1. Du will be what? Minus x minus y dy. So I have, this is about the minus and his minus. So it will be minus du over u. So that give me what? Minus x minus y minus 1 plus c. Okay, now integrate. You'll get what? Minus ln x minus y minus 1 equal x squared over 2 plus c. Okay, now I want to manipulate it. I have what? Ln x minus y minus 1 equal minus x squared over 2 minus c, also I will call it c plus c. Okay, so I have absolute value x minus y minus 1 equal e to the power c, e to the power minus x squared over 2. I'll do the trick plus or minus ec for the absolute value. So I have e minus y minus 1 equals c e minus x squared over 2. In other words, I have e minus y equal 1 plus c e minus x squared over 2. Take ln, so I have minus y equal ln of this. So y is minus this, minus ln of this. Yeah. This is my solution. So there is a minus sign missing. Okay. Yeah. Now we'll go to the old exam problems. We'll do some of them. Yeah. Yes, and be sure I am in the right place. I'm not missing anything. Yeah, I missed this one. But we'll do it later. Yeah, it seems to be difficult, but it's an easy one. You have what? Here I have dy over y plus 1. This is the y things. Minus cosine x over 2 plus sine x dx. Yeah, very clear. Now it's separable. Integrate. So I have ln absolute value y plus 1 equal. We have to integrate this. Very clear. I'll take this is u. This is the u with the minus sign. So it will be minus ln 2 plus sine x. Derivative is cosine. C. Okay. Take e. I have absolute value y plus 1 e to the power c. This one, I'll take it as over 2 plus sine x. So I have y plus 1, do this trick plus or minus. It will be c over 2 plus sine x. What he want? I want y equal, huh? So y equal c over 2 plus sine x minus 1. I have y at 0 equal 1. 0, so I have 1 equals c over 2 minus 1, correct? Yeah, sine 0 is 0. So I have c equal 4. C equal 4. So it means y is 4 over 2 minus sine x minus 1. What I want, y at pi over 2. That will be 4 over 2 minus 1, which is 3. Which is not 3. This is plus minus, sorry. This is plus 1 minus 1. So this is plus. So it will be 4/3 minus 1, which is 1/3, which is this. Yeah, I think I will stop here. I don't want to have a long, and I think we practice a lot of questions. So let me stop here. I'll stop the recording. Thank you.